Hello and welcome. Today we're having an unusual equation. Where is it coming from? It comes from, it's not actually, I've changed the numbers, but it comes from some of my oldest books, which is the book on high algebra by Hall and Knight, which is from the late 1800s. And no calculator allowed, of course. And this is clearly a quartic. And how are we gonna solve something which looks like that? Today, of course, no challenge. We have computer algebra systems, and this particular one does have some nice integer solutions. So we can actually persevere and use the factor theorem, pick up eventually a couple of factors. The numbers are going to be quite disgusting anyway, quite big, because obviously the 385 on the right hand side. And eventually it'll be reduced to quadratic. We can solve it, but we're not going to do it like that. I just want to show you a little technique for something like that, and it's what to look for. We got 4 brackets. There's a reason why it's been written like that. If you look at the gap between the numbers, is going in 2s, 3, 5, 7, and 9, which means if you multiply any 2 brackets which they're 2 apart, okay, as long as if it's a minus with a minus, of course they will add, okay. But if there's a plus with a minus, for example, the 3 with a 5, it'll give you a plus 2x in the middle term. If you do the x plus 9 with the x minus 7, again it's going to do a plus 2x, and so on. If you do the x minus 7 with the x plus 5, it's going to give you a minus 2x, and so on. So it's things like that we need to observe in this particular question. So if we rewrite it, and let's say we write it as x plus 9, and we want, of course, to create something like that. So we're going to go for an x minus 7. So that and that together. And again, we're going to go the x plus 5 with the x minus 3 is equal to 385. And of course, we're going to multiply the brackets in pairs. So it's going to be x squared plus 2x minus 63, and the other double bracket is going to be an x squared plus 2x minus 15 is equal to 385. And have we made progress? The answer is yes, because if you look at this expression now, we got an x squared plus 2x and an x squared plus 2x in the other bracket. So we can say, okay, y minus 63 multiplying y minus 15 is equal to 385, which of course y is kind of obvious, is x squared plus 2x. Now 63 times 15 is 630 plus 315, half of that, 945. So I'm going to have a y squared minus 78, lots of y, plus 945 is equal to 385, and we're going to tidy this up further. 945 subtract 385, 5 from 5 is nothing, 8 from 14 is 6, 1 for 560. So it's going to be plus 560 is equal to 0. Does that factorize? Okay, we're going to look at 560. Start with, so let's say, 1056. That gives me 66. 28 and 20, that goes the wrong way. Because, of course, that's, again, 560, but it's getting smaller. 14 and 40 is exactly the same, really. 14, 28, 560, but that's even smaller. So we're looking for something which is smaller on this. Sorry, that's small and that bigger, but still 560. So, what else comes to my mind? 7 times 80 is 560, but that gives me too much. So there must be some number in between the 7 and the I'm writing it the wrong way. So we got it as. So there's something in between, and it's got to be an 80. Sorry, an 8. 8 times something is 560 is 70. Okay, we found it. So in fact, this is now the 560 and there's a 78. So that's been factorized. So that is in fact a 70 and an 8 minus and a minus equal to 0. And we can finish the question because, of course, now we have just two separate quadratics to solve. So the first quadratic is y minus 8 must be equal to 0. So that means your y is x squared plus 2x minus 8 is equal to 0. This will factorize nicely in x. So we got solutions. X is either 2 or negative 4. That's from this bracket here. The other bracket, y minus 70 is equal to 0. X squared plus 2x minus 70 is equal to 0. Two numbers that multiply to 70 being 2 apart. I don't think they exist. So we complete the squares, not that difficult. And if they do exist, we'll pick them up from the completing of the square. Is equal to 71. They don't exist. The square root of 71 is, of course, a third quantity. Is equal to plus or minus the square root of 71. And therefore, x is minus 1 plus the square root of 71. Or minus 1 minus the square root of 71. And we have solved this particular equation. As I said, this particular one can be solved because it has integer solutions. We could have expanded all of this and just tidied this up into a quartic, and then hopefully would have found factor 2, then factor minus 4, then divide it down to a quadratic of some sort. And then, of course, the quadratic would have given us these two solutions and would have done it. But it was nice to actually see some unusual techniques and things which are useful to observe in some of the more advanced papers such as STEP, AEA, and I don't know what other papers are there these days to test your mathematical wit. Okay, I'm going to be signing out. I'll see you real soon. Bye for now.